today I'm going to be discussing mapping the distribution of homelessness via remote sensing. And of course, as many of you might recall in maybe your drive to work today, this is the issue that we often see, that homeless encampments are very visible and very, you know, problematic, as was alluded to previously. What we noticed, though, is also that there's a real lack of protection for those who are actually in encampments versus who are in homeless shelters. And in fact, that's reflected in the health conditions that are disproportionately affecting the homelessness. Of course, there's an issue with cause and effect here. Mental health and disease could be a factor in homelessness, but it can also be one of the reasons, it can also be caused by homelessness due to the constant stress of being outdoors. There's also greater risk of HIV infections, alcohol use, skin disorders, lack of being able to clean oneself, burns, effects of drugs, etc. So it shows you that homelessness obviously is extremely problematic and is a constant goal of us to try to figure out how to address it. And of course, homelessness seems to only be increasing. Here we show the number of homeless in the city of LA, as well as LA County over time from 2015 up to right here is 2023. LA City has starts from about 25,000 homeless to nearly 50,000, so near doubling in about in less than a decade. And LA County as a whole goes from just under 50,000 to about 75,000. But there are two issues that come from this. One is that this homeless count depends on more or less a guesstimate. There are people that go out and survey the LA County, and they try to see where they find homeless, and then they they estimate the number of people who could be homeless based on what they observe. These point-in-time counts are certainly very, very important, but there's room for improvement. And more importantly, while we have these counts in LA, and they're actually quite good comparatively, there are other cities where the homeless counts are determined by something like you have a free dinner, and those who come to this dinner are counted. So these are some methods are much more comprehensive than others, meaning that we cannot easily compare homelessness across cities, and therefore correlates what actually causes homelessness based on the differences between cities are hard to compare. More important, and just as importantly, these are yearly counts. So if we wanted to determine, for example, the immediate effect of a policy, such as what the LA mayor was doing, for those of you who actually might have seen or heard the LA mayor's State of the City a few days ago, she was mentioning the policies that she was trying to do to combat homelessness. It would be good, actually, to try to figure out if we can see an immediate change to any of her policies. So to that end, I had two questions I want to ask. And these are broad goals, not necessarily that are answered in these slides, but one reason we want to actually capture homelessness in AI is to understand what factors contribute to homelessness, as well as what methods are effective to end it. So to that end, we want to also consider very important ethical considerations to avoid surveillance of the unhoused. Therefore, what we do is we keep models and data secure, only share data after signing a data transfer agreement. We expect to purge data quickly, and only aggregate data is shared with non-researchers. One of the many reasons why we do this, not just because it's ethically good, but because there are examples where this has been carelessly done, such as a few days ago, this article by The Guardian about San Jose and their use of AI to track homelessness. So our methodology was where we annotated several places in LA that had homeless encampments, and we specifically looked at homeless encampments because they're the hardest to track. People in homeless shelters are one can actually get an account for. And so the first thing we did was we said, okay, we have these annotated tents, and we have random images in the LA city, We train a model to figure out where the encampments are. And what it basically learns at first is that homeless encampments tend to be in downtown. This doesn't actually reflect the true distribution of homelessness. Instead, we do actually a second step where we compare these negative examples where homelessness does not occur in random images here and compare to our training data. These are sort of better negative examples, and we actually get a much better distribution. There's some outliers here, which it's not shown here, but we remove by just removing greenery. It happens to be that for some reason, homelessness, the AI model thinks that these forests are homeless encampments. But in fact, they're obviously not. But this is easy to remove. The outcome, though, is that we get, with a few rare examples, a very high precision homelessness. So among about 290,000 satellite images, about 70 by 70 meter satellite images of LA, we extract about 180 images that are likely homeless. So we get an extremely high true positive rate, given the sheer size of the data that we're extracting. What that means is that we can do things like even figure out the count of homeless. So first we have a classifier to say if there's homelessness in these areas, and then we actually annotate where these homeless tents are. And so we use a model that's called a segmentation model to be able to determine the actual individual blocks of homeless encampments, and thus we can automatically assign these as scale. The end result is that we have the model to determine the defined range of distribution of homelessness and in a complementary count to the official homeless count. So our official homeless counts may only look at hotspots. Our method could look at places even that are quite remote and hard to spot through by human, hard to spot from a human looking along major streets. And so it allows us to sort of have a count both in LA and across the US, therefore making appropriate counts. Now, we acknowledge that we can't see everything. In fact, we're complementing the satellite view with Google Street View, which can detect homeless encampments underneath bridges, for example. And in fact, we've actually created a large, I think a few 100,000 Google Street View images, and we captured where they are with respect to nearby overpasses. But to conclude, we find that AI can actually detect homelessness. We can find the number of encampments, and we can incorporate Google Street View images to detect where satellites cannot see. And we address the ethical analysis of homelessness by understanding where people live and why. And we want to learn factors to reduce homelessness while also not sharing this data to people that could cause homelessness. So, thank you.